Hello everyone, this is the lecture series of hydraulic machine subject, and this is a BTech 5th SEM mechanical engineering subject, and the course code of this subject is ME317, unit number 3rd and lecture number 24. For this today lecture, the topic is here pressure control valve. So today only I am discuss about the pressure control valve, and this topic comes under the hydraulic system, and this is the unit number 3rd is here. For my introduction, myself Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan, Vihar University, Jaipur. In this topic, I will teach about the pressure control valve. And pressure control valve, this is a pressure reducing device used in hydraulic system, and if any case of parallel or series hydraulic system, in both cases pressure control valve are given the one way to control the pressure inside the fluid lines, and these fluid lines transfer the fluid from the pump to the output devices. These are the actuators. So here the different type of circuits are used. First, the fluid goes to the hydraulic pump to selector valve. These are called direction control valve, and then flow is goes to the actuator, and this is the different types of actuator are present here. Some actuator are two-way valve actuator, some are the one-way valve actuator. This depend on the characteristics of the actuators. So pressure control valve, or we can say that this is a pressure relief valve. Both are same. The pressure control valve, these are sometimes called the pressure relief valve, and this is a working procedure like if any extra pressure inside the fluid lines, at that time this pressure control valve are open and send these flows, high pressurized fluid, into the reservoir. So this pressure control valve, it protects the hydraulic circuit, and it also provides the fail-safe circuit for the hydraulic system. So go to this objectives of the pressure control valve, and by the end of this section you should be able to understand about the concept and operation of the pressure control valve. Or a pressure control valve is a part of a device or machine that helps to achieve the control of the flow. Is here, and here actuator is a device which convert the energy. Means it convert the pressure energy into the pressure energy of fluid into the mechanical work. So in the case of actuator, these are the different types. It may be electrical, hydraulic, and pneumatic type of actuators. So actuators are the different types. One is electrical operator, hydraulic, and the pneumatic operator. And for the several thing of this here is different types of control valves. In this chapter, I will discuss the operation of different types of control valve. So you will also, or a student also, able to understand about the concept of different types of pressure control valves here. So we move to the introduction of this, and these are the outline contents of this lecture. First is introduction, and then classification of pressure control valve, pressure relief valve, direct acting relief valve, pilot operated relief valve, and sequence control valve, and the conclusion means what type of action created by the pressure control valve, and references means this these are the some points how where it will taken, right? So these are the references. So move to the next. This is the part of the introduction. For the part of the introduction, here pressure development via restriction means it provides one kind of restriction in the fluid line. If any extra pressure, suppose for the restriction case, if any extra pressure inside this fluid line, if any extra pressure inside this fluid line due to contamination of contamination of fluid, contamination in this case of some any extra unwanted thing present in this fluid lines. So in that case, these fluid line choke. At that time, the fluid line choke, and unnecessary pressure is increases. If unnecessary pressure is increases, so you know already PV equal to nRT. For this relation, if pressure is increases, this is the ideal gas relation, and this will apply in this fluid also, because water fluid here is fluid and liquid as a fluid here. And in the case, suppose this type of pressure valve is also used in pneumatic circuit. In the pneumatic circuit, air used as a fluid. So this is the ideal gas equation. These are the PV equal to nRT if pressure increases. So pressure is directly proportional to the temperature. So temperature of the fluid is also increases, and this creates a very critical effect inside this fluid line. So it may be crack, or it may be blast of the hydraulic circuit, or any sudden chances are happen, right? So prevent these type of unnecessary things. So prevent these kind of unnecessary things. We used here pressure control valve. So it control and check of the developing pressure. Thus pressure relief valve is used for the manipulation of pressure and flow of oil in different circuit. Means it also provide the flow of the different circuits also. Suppose any time for the case of JCB or any other fluids, so pump is always running. In the hydraulic circuit, pump is always running. Similar to the human body, here is heart. Heart is always running, and it pumps the fluid. It pumps the fluid means it pumps the blood over the arteries and veins. And if you choke this hand like this here, so blood is stopped. Blood is moved from my body, and this is stopped at this position. So it creates a extra unnecessary pressure inside this veins. So this pressure is reduced by the any other one kind of device. This device is called the pressure control valve, and it reduces the manipulation. It reduces the manipulation of pressure and flow of oil in the different circuits. And for the different circuit, meaning here you can use parallel circuit line, you can use series circuit line for the pressure flow, and you can also use the series and parallel combination, series and parallel combination of the hydraulic circuit. And This is the term related to the pressure valve. The term related to the pressure valve, this is the cracking pressure. And this is the pressure created inside this valve, at which the valve just begins to bypass the pressure, bypass the pressurized fluid to the reservoir. It is called cracking pressure. Means at that time this pressure valve is open. At that time pressure valve is open. I will discuss the internal part of this cracking pressure here. At this pressure, the force developed by fluid. At this pressure, the force developed by the fluid at ball or poppet just overcome the compressive force of the spring retaining ball or poppet or valve seat. So this is a definition of this cracking pressure. And then move to the next page. Fluid starts by passing through the valve and the poppet gets lifted from its seat, and the lifting of the poppet causes compression of spring, and as spring gets compressed, its force on pressure increases. Its force on the pressure increases. At that time, the spring, suppose that this is the extended position of the spring, and the contact position is only this much. Contact position is only this much. So spring is contract and allow more passage to fluid. For free flows requires more pressure. So for this case, at the time the fluid flow through relief valve is at much high pressure than cracking pressure. At the cracking pressure, this is the pressure when the valve is open. When the valve is open, and at this time the valve is fully open. And this time valve is fully open, and the pressure at which full flow of pump bypasses to the reservoir, and this pressure is called the full flow pressure. And our next thing is here. These are the different types of pressure control valve. These are the different types of pressure control valve. These are 6 types of pressure control valves are pressure relief valve, unloading valves, sequence valve, pressure reducing valve, counterbalance valves, and the safety valves. These are the 6 types of valves associated to pressure control valves. So we will discuss one by one. Here is pilot operator relief valve is present here. Pilot operator relief valve. In this case, this is the figure of the pilot operated pressure relief valve. So here this is the inlet side. From the inlet side, and it pushes the high pressure, and this fluid goes to this line from this here. This is the vent port, and this is connected. Here is one plug is connected inside it, and this pressure gives a force on this pipette. So this pipette suddenly open, and then liquid is passed through this line to again this line. Here 2 types of spring are given. Here 2 types of spring are given because it prevents 2 types of pressure. So first we give this pressure on this line. So first this contract this spring, and if this spring is fully contracted, then the fluid is go to the this line and then pass to the outlet. This is the tank line, right? This is the tank line of this spring of this valve is here. And if I am talking about the component here, the different component are present here. This is the spring of the poppet, or this is the opposite spring, and here this is the adjustable screw to adjust the working pressure of fluid, to select the working pressure of fluid. And here this is the spring for a spool to force it on valve seat, and here light in compression, and this is the spool chamber. Here this is the spool chamber, here orifice in spool, this is the orifice in the spool, and here the input line is connected here in this case, and this is the tank line, right? So I am already explained about the working of this pressure reducing valve. And in case of direct acting relief valve is pressurized. In case of the operated relief valve, in case of direct acting relief valve is pressurized, fluid is stopped by spring loaded poppet against by passing through to the reservoir, while in case of pilot operated relief valve, a balanced piston or a spool block the passage of the pressurized fluid against bypass to the reservoir, and excess pressure cause unbalances of the piston, because of which it slides to one side, allowing pressurized fluid bypass to the reservoir. So this type of valve where is used where the high pressure is required, inside the fluid line, because it provide a pressurization in two types. Just you see here, in this you see here, this is the inlet from the pump. At the if any normal pressure is present, then it goes to the this side, and then here this forces, and then liquid is less pressurized, and then is moved to the reservoir or moved to the tank from this side. If any very high extra pressure is created, at that time this piston is moves up. And if piston is moves up, then this side is open, this seat is open. So first I will discuss about the pressure relief valve, right? And for the case of pressure relief valve, and it is short term is called as a pressure relief valve, just like as a PRV. This is the pressure relief valve, and this is the function of the pressure relief valve is to limit the pressure to prescribed maximum by diverting some of all the output of pump to the tank. And pressure relief valve or the relief valve is a type of safety valve used to control or limit the pressure in a system. System means the hydraulic system, right? And the pressure might otherwise build up and create a process upset, an instrument or equipment failure or fire. The pressure is relieved by allowing the pressurized fluid to flow from an auxiliary passage out of the system, and the relief valve is designed to open at the predetermined set pressure to protect the pressure vessels and other equipment from being subjected to pressure that expected their design limits. And when a set of expected pressure, the relief valve becomes as a path of the least resistance, as the valve is forced upon the and portion of the fluid is diverted through an auxiliary route. So in system containing flammable fluids, and this reduce the any unwanted things, because any unflammable fluid is present inside this system, flammable fluid. So this increase the flame, right? This increase the tendency of the burning of the fluid, and because if pressure is high, then temperature is also increases, and this type of pressure relief valve gives the different types of points, and these pressure can rise in a hydraulic system if the flow rate from the pump is larger than the flow rate through actuator. The flow rate from the pump is larger than the flow rate through actuator, and the volume of a closed system is reduced, and the hydraulic resistance of the system rises. And the pressure relief valve are normally closed, right? So these are the some points regarding the pressure relief valves, and if pressure can rise inside this hydraulic system. So for the case of next is and this is the construction of this simple pressure reducing valve or pressure control valve, and it consists of a valve body. This is the valve body of this pressure control valve, and poppet, spring and adjusting screw, and this is the adjusting screw, and this is the valve body. Here is this dotted terms is known as spring, and this is the tank line. Here this is the output side, so this is the tank line, and from the line, this line, oil bypass through the tank, and this is the poppet. This perform the main function of this opening and closing of the valve, and this always act as a spring loaded, right? And a spring hold poppet on a valve seat, and this is the inlet of the pressure, and in bracket this is the pressure line, and when pressure is less than spring compression, valve remains closed. Valve remains closed is here. So this pressure is called the pressure line, right? So this is the construction of this valve, and then move to the next. In this case, this is a this figure represents the system of this pressure control valve or pressure relief valve, and this is the systematic symbol. So here this line, this single line shows the inlet of the fluid. This shows the inlet of the fluid. It means fluid is comes this side and goes to the this side. And this is the reservoir. Or tank, and this line shows the tank line, right? Here this rectangle shows the valve body. And this is adjusting spring. Here this is a one adjusting spring. This is given by this like this. This is a variable arrow, and this is the pressure line and acting against spring. And these are the some symbolic representation of the pressure relief valve, right? And So for the working of this pressure relief valve is, if any extra pressure inside this fluid line or any extra pressure created inside this fluid line at this time, at this time this valve is open. But how this valve is open? This valve is opened by, if any extra pressure inside this fluid line, then this pressure created to this pipette, and if this is shown by the red line. This is shown by the red line in this figure, and this creates a force on this pipette. Then pipette contract the spring. And this pipette provide a passage to the flow in between inlet to outlet. So these are the, so this is a high pressure zone and here is a low pressure zone, right? And this pressure of fluid, pressurized fluid, goes to the reservoir like this. So this is the simple working of this pressure reducing valve. Here is pilot operator relief valve is present here. Pilot operator relief valve. In this case, this is the figure of the pilot operated pressure relief valve. So here this is the inlet side. From the inlet side, and it pushes the high pressure, and this fluid goes to this line from this here. This is the vent port, and this is connected. Here is one plug is connected inside it, and this pressure gives a force on this pipette. So this pipette suddenly open, and then liquid is passed through this line to again this line. Here two types of spring are given. Here two types of spring are given because it prevents two types of pressure. So first we give this pressure on this line. So first this contract this spring, and if this spring is fully contracted, then the fluid is go to this line and then pass to the outlet. This is the tank line, right? This is the tank line of this spring of this valve is here. And if I am talking about the component here, the different component are present here. This is the spring of the pipette, or this is the opposite spring, and here this is the adjustable screw to adjust the working pressure of fluid, and here this is the spring for a spool to force it on valve seat, and here light in compression, and this is the spool chamber. Here orifice in spool. This is the orifice in the spool, and here the input line is connected here in this case, and this is the tank line, right? So I am already explained about the working of this pressure reducing valve. And in case of direct acting relief valve is pressurized. In case of the operated relief valve, in case of direct acting relief valve is pressurized, fluid is stopped by a spring loaded pipette against by passing through to the reservoir, while in case of pilot operated relief valve, a balanced piston or a spool block the passage of the pressurized fluid against bypass to the reservoir, and excess pressure cause unbalances of the piston, because of which it slides to one side, allowing pressurized fluid bypass to the reservoir. So this type of valve where is used where the high pressure is required, inside the fluid line, because it provide a pressurization in two types. Just you see here, in this you see here, this is the inlet from the pump. At the, if any normal pressure is present, then it goes to the this side, and then here this forces, and then liquid is less pressurized, and then is moved to the reservoir or moved to the tank from this side. If any extra, very high extra pressure is created, at that time this piston is moves up. This piston is moved up, and if piston is moves up, then this side is open, this seat is open. So here two things pass the system to the reservoir, right? So this is a working of this pilot operated pressure relief valve. Then move to the advantage of this valve. So for the advantage, it creates the smaller package on larger pipe size. For B, more option, and the seals for more tightly as system pressure approaches but does not reach the set pressure, and control pilot can be mounted remotely, and it can be used in engines also. And the disadvantage for this pilot operated valve is here, it is more complex, resulting in various fail open failover modes, and it is more expensive and smaller in size, and it creates a small part in pilot valve are sensitive to contaminants of the particle, and this is the sequence valve. The function of sequence valve is to provide flow to a second consumer in the case of when the pressure level at a particular consumer has reached as threshold level valve. So it can provide the sequence of operation of the actuators. Sequence of operation of the actuator, as the name implies, it is used for sequencing the operation one after another. The best example for the sequence valve is to landing gear of the aircraft, and landing gear bogie. So in the sequencing operation, first landing gear, if for the retraction mechanism, first one valve is open, then retract the landing gear in downside, and then lock the nut. So these are the operation present in the sequence valve. This is the, here two actuators are present. So this is the clamp cylinder and this is the extender cylinder. So here only one pump, and this is the direction control valve, and this is the pressure relief valve are attached here. And this is the check valve. This allows the flow at only one direction, right? And here is, this is the 3D view of the sequence valve, right? So move to the next. These are the different types of application. So such application is mostly for in tooling and automation purpose, and when several operations are sequenced in predetermined manner. A check valve is connected in parallel with sequence valve so that both cylinders will retract simultaneously. No sequencing is desired in retracting case. So these are the different types of application of sequence valve. And then move to the next slide. This is the counterbalance valve. For it control the flow of operation in two actuators. right? And it is also known as a back pressure valve. So in this case, this is the figure of this pressure control valve, and then move to the next. This is the operation of this lift section for the vertically moving object, and next is here. This is the 3D diagram of this pressure control valve, right? This is the 3D or actual diagram of this pressure control valve. Here these are the fluid lines, right? These are the pressure reducing valve, are the just like a valve, safety valve, right? Move to the next. This is the operation of this lift section for the vertically moving object, and next is here. This is the 3D diagram of this pressure control valve, right? This is the 3D or actual diagram of this pressure control valve. Here these are the fluid lines, right? These are the pressure reducing valve, are the just like a valve, safety valve, right? And next is here application. And these type of valve are mainly used in forklifts when heavy loads are to be brought down, and also used in loaders and JCB for easy load pickup and lowering of loads, and the hydraulic machines also. It uses the hydraulic machine also. So move to the next here. This is the pressure reducing valve, and the pressure reducing valve, this open pressure control valves used to maintain reduced pressure in the required portion, and it done by the increasing the area where the oil could release the pressure. This is the figure of this pressure reducing valve, one type of pressure reducing valve, and this is spring operated, right? These are the different kinds of application. So first application is air compressor, used in inlet of flow of load in pressure reductors. It is used also in aircraft and aerospace industry, cooking water pressure reduction, and oxy-fuel welding and cutting also, and propane PG gas industrial application, transportation and storing, and mining industries. So different kinds of application related to this theory. And then next is here safety valves, and this is the last topic of this lecture here. Safety valve, all the pressure relief valves are kind of the safety valves here. So safety valve are the valve that act as a fail safe in the thermal hydraulic plant, and safety valve came to existence as the early steam boilers were prone to explosion. So for the figure of this safety valve, so this figure, these two, these are the safety valves in the hydraulic system, right? Then move to the next section of this lecture. This is the MCQ problems. So go to the MCQ problem for this lecture. This is the first MCQ problem, and which is not an output device. These are the 4 options are given. First one is 7-segment display, liquid crystal display, lithium battery indicator, and the lithium battery. So option D is right answer. This is not a output device, right? And then move to the next question. Question number 2 is here. The question number 2 says that who invented hydraulic press? Means which scientist invented by the hydraulic press? So 4 option is given here. First one is Norbert Werner. Option number B, Joseph Brahma. C is Charles Young. D, Charles Wheatstone. So these are the 4 options. So what is the correct option of this? So B is the Joseph Verma is the inventor the hydraulic press. So B option is right. And move to the next question. This is the question number 3. And what control the direction of flow of oil? This is the pressure relief valve, direction control valve, flow control valve, and actuator. So here direction control valve control the pressure inside this fluid line. Means it provide a one way to how here is fluid is goes, right? And the next thing is here. This is a one numerical problem. What is push provided by the water used in fluid based actuator? If a wooden ball of a radius of 3 cm is immersed in it, given that the water has a density of 1000 kg per meter cube and wood has a density of 900 kg per meter cube, then take G equal to 10 meter per second square. A is here 1.695 Newton, B is here T 3.2 Newton, C 2.26 Newton, D is 1.13 Newton. So the correct answer, if you solve this question, then you will get a correct answer for this question is here. D is the correct answer, 1.13 Newton for the correct answer. Then move to the next question. This is question number 6. This is also a one numerical question. And what is the push provided by a hydraulic fluid used in fluid based actuator? Used in fluid based actuator if a steel ball of radius 3 cm is immersed in it, and given that the fluid has a density of 2000 kg per meter cube, take G equal to 10 meter per second square. Take G equal to 10 meter per second square. And this is the A option 5 Newton, B option is 3.2 Newton, C option is 2.26 Newton, D option is 4 Newton. So the correct answer of this question is 2.266 Newton, right? And then move to the next question number 7. This is question number 7. And what is the push provided by a hydraulic fluid used in fluid based actuator, and if a steel ball of radius 3 cm is immersed in it? And given that the fluid has a density of 1500 kg per meter cube, take G equal to 10 meter per second square. So for this case, A equal to 1.695 Newton, D 3.2 Newton, C 2.26 Newton, D equal to 4 Newton. So the correct answer is here. A is the 1.695 Newton. It is the correct answer for this question. And then move to the next question, question number 8. Which component of a hydraulic system is used to store the sufficient amount of hydraulic oil? This is the rotary pumps, oil pressure, flow control valves, and pressure gauge. So the correct answer is here. Oil pressure is the one way to store the hydraulic oil. Next question is here. 9 number. Which among of the following are not a work parameter of the fluid? These are the direction, speed, pressure, and temperature of the flow. So D option is right here. This is the temperature of the flow. This is the right answer for this question. This is the last question. Which among the following are not the main selection criteria of the control valve? These are the type of actuation, environmental condition, space requirement, and software support. So D option is right answer. This is a software support for the right answer of this question. And then move to the next page for the references of this chapter. So these are the different kinds of references used in this chapter. So just you see these are the references. And then thank you for this kindly listening this lecture, and thank you all of you. Thank you.